All right, so good morning, everybody, and we're going to continue on here with our morning session that'll key off of what we started with this morning. And I just wanted to let you know that on that back table, when you leave today, I've printed out a resource of what the OSHA standard and the guidelines are, and in that there's an index that or a table of contents that outlines all of the things that we're going to be talking about, and you can have that as a takeaway to review. So, excavation and trench safety for on-site wastewater systems. As I said this morning, we are a group of small businesses that have a challenge in terms of being able to either allocate or identify the resources that we need to put these full, or at least understand what the rules are regarding OSHA and excavation and trench safety. But for the next hour or so, we're going to just kind of go through them and just touch on the high points of them, and then take a look at a couple of case studies and how this actually works in action. Now, this material that we delivered, or that we're giving to you today, was developed under a grant from OSHA that we received specifically for our industry. And part of the deal is that I'm here today to talk to you guys about it, but the training resources that we've also developed, we're going to give to TOWA, and they're going to be able to take that forward and put it into their training program, and so that over time we'll be able to continue to get people invested in understanding the requirements of the rule, and then also but make workplaces just safer. So the excavation, trenching, and shoring, part one of this is the scope, application, and definitions, and it applies to all open excavations made in the earth's surface. This is their language in the rule. And excavations are defined to include trenches. For us in our industry, the most common exposures that we have are tank excavations, the side sewer work that we do, soil test pits, depending on where you're at, and then the other work that our construction companies do that when you can't, I'll say when you can't make a full-time living doing installation of on-site systems. And so it's utility work, side sewer work, sewer lines, and we're going to take a look at some of those systems in a couple of the case studies that we're going to do. I want to ask a question just with a show of hands. Do you in Texas dig soil test pits instead of perk holes to do your soil determination? Yes, generally speaking? So there's lots of different counties here. Are there counties that just do soil perk tests for soil determination? They just all okay. All right, so we're gonna spend just a second on that as well. So a few definitions here we'll go through real quickly. Excavation, any person-made cut, cavity, trench. This is the language straight out of the rule. Tank excavations are a big part of where we're at, and this is just not untypical of what happens when we're putting a tank in the ground and we're trying to get it set properly. And so part of what we're going to be talking about are some ways that we can figure out how to provide the protection that we need under the rule, and then also to minimize the exposure, up to and including how can we do this job without getting in the hole, right? And stuff. And so a trench definition, it's narrow in relation to its length, and it's not greater than 15 feet. And the rules that go along with that. Here's just a couple of pictures showing an unprotected trench and kind of about the same depth trench with some protection in it. Cave-in. This is what we fear the most. And so when something comes off the sidewall or from surge loading above the excavation outside, it happens suddenly. You saw in the bit this morning that dirt coming off of a sidewall happens at 45 miles an hour. And I don't know about you, but I cannot run that fast in a trench or anywhere. Yeah, really. But and the other part of this is the rescue operations that follow on. I mentioned and asked for a show of hands of how many folks were firefighters here. And I always, when I look at this, I think about work process flow, and I think about what happens next. right? And so if you're in these excavations and something goes sideways, what happens next? Do I have communication? Because I'm working in a remote area. Is the service provider for my phone, do I got enough bars to call somebody if I'm even going to try and call for help? And part of what the rule gives you some guidance on is to work through all of those workflow processes from beginning to end to sort out really some of those questions. So there's a couple of different protective systems and methodologies that you can use that really range from how you're going to lay back the slope. It has some determination with depth, or if you're just going to use a trench box and go about it that way. How many people here own a trench box? Few? Okay, so do you know where to rent one? Well, who's the big outfit that in Texas that in Washington it's called United Rentals, is one of the big guys, and they've got trench boxes, they've got tripods and air quality monitoring devices for confined space entry. Do you guys have a company here in Texas that does that kind of stuff that you've got access to? It's good way to go. Shoring, another method that is available where you can use metal hydraulic shoring, or you can build it if you want, and you can build it in place. There's some guidelines that are in the rule that also allow you or give you some guidance on depth, timber sizes, and the materials that you can use if you're going to build them. By and large, for the typical on-site application and uses that we're involved with, timber shoring isn't really an option, I don't think. There's just too many other things that are just way easier and way faster. So sloping definition, protecting employees from cave-ins by excavating to form sides. So depending on really what we're talking about as it relates to like a residential installation of an on-site system, we're going to have the tank that we put in there, and or depending on what's going on with the drain field, it's important to minimize the impact to the drain field area. And we get into tight sites and small sites dimensionally. I mean, we're doing what we call Table 9 repairs on sites less than 12,000 square feet with a house on it and a driveway. And so the footprint that we have to work in is pretty small. And so for us, sloping is not really one of the better options to choose when there's alternatives available. So pre-engineered shoring system has cross braces and hydraulic cylinders. And you can see in this picture there's also this sheeting that you can put in that is also described in the rule for what it's supposed to look like. And so it's not quarter-inch, beat board and things like that. There's some characteristics around it that'll ensure that it's designed to do the job that you're asking it to do. In smaller work, and we're going to see an example of this a little bit later on, of a project where it was residential. It was a cut across the street, and they had come with all the equipment in a box, and they put it in place and then never moved it and continued to work as they were doing the project for that day. A big part of the OSHA definitions is this one right here, is using tabulated data. And so this is the table that when you go to your rental company, that you're going to give them basically the specifications on your job. How deep's the trench? How wide is it? How long is it? What's the workflow going to be? And they'll use tables like this, and it's like our proprietary device, pre-treatment devices that we have. Those are pre-engineered systems. Some of these protective devices, like the boxes and stuff that we use, are kind of the same thing. They're pre-engineered. They're designed to take the side loading and the use that we have in the excavations. As I said this morning, this is probably one of the real keystones to an effective excavation and trench safety program on the site, is identifying your competent person. And within the rule, they go into some more detail about what all of those things include, but it's somebody who can identify existing or predictable hazards. And so if you think about weather changes and all of a sudden you get a whole bunch of rain and it changes, or if you think about an excavation being open for some period of time, just oxidation in different types of soils can tend to destabilize them. He has the authorization or authority in his job to take corrective measures to mitigate the risk, and can even, if necessary, shut down the job till they get whatever the problem is sorted out. And he has to be knowledgeable enough in the requirements of the rule to apply them to his job. So looking at general protection requirements, we'll kind of go through these real quickly. There's a number of sections that here, and when you think about them, like I said earlier this morning, I look at this more as a guide to how you can do this work. And so these are just kind of triggers for some of the things that you want to think about. So surface encumbrances, what are the things that are outside of the trench that can impact the workers that you have, or the guys that you have down inside? And you have to make provisions for that kind of stuff. You'll see this picture and others all related to this same job, but this was this 2,100-foot sewer line, 22 feet deep project that these guys were working on. Had never done a job this big before, and so this was pretty much all new to them. They really didn't have, I'll say, if not an understanding or an execution of the excavation and trench safety code as it relates to this, but this is the stuff that they were facing with on the job. This is where the competent person comes in and starts to make some decisions. So when you look at this, what are the things that impact this sidewall underneath here, that and undercutting that's going on here to do this? This was essentially 22 feet of sand and material that looked just like this, top to bottom. And so, and that's a big piece of equipment. And so you think about point source loading. You think about equipment operating while it's they're vibrating. All of that stuff is impacting that immediate work environment. And we were on this job for a couple of hours, and the material falling in, here was continuous throughout the entire time that we were there. So underground installations, everybody knows about. Call 811 and utility locates. You're responsible to understand those, call them out, and stuff. What a lot of guys that I know do. How many of you have your own equipment to locate? Anybody? Do you depend on 811 to do it? Mostly. So as I've asked this question across the country when we've done this, how close are they with their locates? And I good? 3 to 6 feet. I mean, it's those kind of numbers that you just locally you just get to be aware of over time. I've heard everywhere from 18 inches to 12 feet, and it's kind of take your best guess or your dig, because you never know what you're going to get into and where it's going. So when an excavation approaches the location of underground installations, this starts to get from general to specific. You need to determine exact location of the installations by safe and acceptable means, because it can be things under pressure, gas, water, power, electrical. And while the excavation is open, you must protect them as well. If you don't do these things, what happens next? Get your checkbook out, right? You're gonna be paying somebody for something. So access and egress, how do people get in and out of the excavation? And this can be ramps, runways, it can be ladders. You need to make provision for the employees to be able to get out, just to do their work activities, but also in an emergency to get out as well. And then it gives some detail for structural members used for ramps must be of uniform thickness. And so now you think about just building code, when what's the tread and rise on steps, and what's the minimum requirements for railings on decks on the back of your house. All of that kind of stuff is also part of these general inclusions into this. And if you're going to put cleats on it, it has to be attached in a way to prevent tripping. Structural ramps that are used in lieu of steps are provided with surface treatments to prevent slipping, so slips, trips, and falls. So you got to think about what's the work environment in it. Is it wet? Is it cold? Could it be icy? And so it just works you through all of these different scenarios. And for a lot of us, you kind of think about those things unconsciously. This just puts it a little bit more into a checklist so you can sort it out more quickly. So stairway, ladder, here's an example of this. In the rule, it specifically says 25 feet in any direction from the worker. You have to have a means for him to get out. And the other thing that you see in this picture is, kind of basic ladder safety, but it has to be 3 rungs above the level of the excavation so that you can get out and you're not in some awkward position as you're trying to clamber out of the hole. General protection requirements also include exposure to vehicular traffic. And so if you got a utility job and it's in the right-of-way and it's on a road somewhere, you've got to have, there's stuff around that for reflective gear, for all these other elements that you include to protect the worker. Exposure to falling loads, wherever they're coming from. For us, it could be septic tanks. One of the questions that I've asked for this is, I think you guys use knuckle booms for a lot of your deliveries. What about tail rails for them as well? And I saw one of the guys out in the back here on Monday unloading a tank. Basically, it looked just about like this. And under the rule, these are, I'm pointing up here. Under the rule, these cables are lifting devices, right? And so the company that's delivering this has to keep track of that stuff because at this point, they're out on the job. There may or may not be a guy down here in the hole, and you're depending on the quality and the integrity of that cable that's on there to come off. How many of you guys have ever seen one of them cables come apart? Yeah, look around, right? And so that's another piece to pay attention to. In our OSHA talk this afternoon, we're going to talk a little bit about more individual approaches to situational awareness around that, but it's like being in the line of fire on some of these pieces here. Warning system for mobile equipment. Again, this is just some fundamental stuff. If you've got equipment moving around on your site, we're going to take a look at this job a little bit more too as we progress through. Hazardous atmospheres. So we work on sewer lines, or when we're working at least on sewer lines, we know or can anticipate that there may be sewer gases that emerge out of when we make the cut to tie into the sewer line that may be there. And so the rule requires you to evaluate. If it may be present, you got to evaluate if it is present. And so in some situations, you may want to do or have the capability to do air quality monitoring in the trench. Some of that depends on the configuration of the trench, how deep it is, how cold it is outside. Are gases heavier than air that are coming out, lighter than air? It's all part of the process that you go through to do that. So this is kind of a continuation of that last picture that we just saw. And an example of this is, they're going to cut into the sewer line that's at the bottom of the excavation down over here. And so they've set up their access and egress, but the ladder is not set up really properly. It doesn't come out over the top of the edge of the excavation by 3 feet. And so the whole thing is awkward. And this guy is a subcontractor that's going down in there with a drill to cut into the pipe. So when he set this job up, I'm taking this picture. When he set this job up, he fired up the generator in the back of the truck, and I'm standing there, and after a minute or two, it's like the exhaust fumes from this thing is really getting fairly obnoxious. So go back to the competent person on the job and think about just one thing that this guy could have done that would have made it, it would have just eliminated that hazard at all, and any of those gases from maybe falling down into or accumulating in the trench itself, is that he backed the truck up right to the edge of the trench, fired it up, and then they went down in there. But this extension cord that he's got that's going to run his drill that's plugged in right here is only about 100 feet long, right? And so all he really needed to do was to move the truck 35 feet down the trench, or away from the trench, problem solved. But they didn't recognize that as a hazard, so they didn't do anything about it. So testing and controls, if you think there's going to be the potential for that, then the methodology that you use for air quality monitors to check it throughout the trench is pretty straightforward. The things start to howl at you if there's something down there that they don't like. There's and the same. If you have potential for accumulation, the same monitor the guy is going to wear while he's working down in the trench is going to be the same one that you can use for testing. So you don't need two different pieces of equipment. And then these air quality monitors test for multiple gases in the environment where you're checking them. So emergency rescue equipment, breathing apparatus, safety harness and line, if they are, basically what this is speaking to is non-entry rescue. Because if you look at any of the statistics around confined space entry or any of these things, if you have 100 deaths, 60% of them are the rescuer, right? Is another work, somebody goes down in a trench or inside of a tank or something, and the worker on the outside sees that and goes down without understanding what the exposure was. I mean, if it was heat prostration or a heart attack or anything like that, that's one thing. But if they went down because of some kind of a gas that put them down in there, the next guy that goes down in is going to go down too. And there are stories of 3 and 4 and 5 rescuers, workers, that are going in to try and do something without really understanding what the risk was. And so, you know, are you prepared? So you got to have this stuff kind of available on site. You want to talk through it a little bit about what I always say is what happens next, and try and be prepared. So in addition to the requirements, you know, you've got to take adequate precautions. And if you've got concentrations of flammable gas in excess of 10%, so there's upper and lower flammable limits that you have to evaluate. This is all done with your control, or with your air quality monitor. In certain circumstances, particularly around confined space entry, but generally speaking, what the rule calls for is mechanical air supply. So it's air volume going in. In the confined space entry course that we do, this is also a key component of this, because in our industry, what we typically do is we'll pump out a tank and then leave the truck on suck and just use the hose to continue to pull air, presumably, out of the tank to keep it clean. But the example is that if you took flour and you threw it out here on the floor, and then you got your vacuum out with the long hose and the nozzle, and you stuck it right there, it would suck the flour up in an area about this big. But all the rest of the flour would still be in there. We have multi-compartment tanks, and that's why mechanically supplied air changes the air in all elements or all parts of the tank, and just is a lot more effective at it. Associated with water accumulation, that job that we are kind of looking at here, the 2,100 feet of sewer line, I was with the project supervisor, and I looked at this, and this was just continually falling in, and I said, on a scale of 1 to 10, where would you rate this? He said, I'd give it a 7. Really? What would make it a 10? He said, add water. That just makes everything a lot more complicated. That's on big jobs, but it also can be on little jobs too, right? Because now you've got things that are coming up out of the ground. How many of you guys have had tanks float on you? Right? So it's pretty common in our industry. If this turns into a full scale repair, then you know, you just want to be able to anticipate what you've got to do for that. Stability of adjacent structures. You know, we get into some tight working conditions here, and you've got to make sure that you've got the foundations and everything are stabilized. My sister in Chicago had a job like this done, and the guy just bumped the wall of her basement, right? And concrete cracks, and this had been in the ground for a long time, and it took a day or two, but eventually that wall collapsed into the excavation. That they were trying to fix the foundation on the deal is what they were working on. So loose rock and soil. You know, we said earlier that the minimum requirement for you to have to do something under the excavation rule is 4 feet. But when you look at a picture like this, and this excavation is where you've got the worker is down in the bottom, there are circumstances and soil conditions where the potential for protection is needed under 4 feet, and the rule calls that out, but you have to evaluate that yourself, and again, that's where the competent person comes in. So we're backfilling here a little bit. So the competent person, there's a requirement for daily inspections of the excavations, adjacent areas, just a workplace inspection conducted by the competent person prior to the start of work and as needed throughout the shift. And so that guy gets to make those decisions on the job to changing conditions. And there should be some mechanism in place for you to record the inspections. Fall protection is required for workers adjacent to the trenches. If they particularly are crossing over the trench from one side to the other, then you have to get a little bit more formal in the structures that you're building, and there's guidance on that for how to do that. You can buy them or you can build them. You have the option to do that. Protection for employees in excavations, using design of sloping and benching systems. You've got a number of options with the slope configurations, but it depends on some of the soil types. I wanted to touch on this one a little bit because of soil test pits. This picture is one that we have in Washington that is issued by the State Department of Health. The State Department of Health, we have a state level rule, then local health jurisdictions adopt those rules. They can make them more restrictive if they'd like. But in Washington, this is the recommended guidance that they give for digging soil test pits. And I took this and I sent it to the Washington State Department of L&I, and I said, does this comply with our state excavation and trenching rules? And they looked at it and they basically said no. And so we're talking and working with our State Department of Health to redo this and republish it. But the challenge with this is for you guys as business operators and owners, and for our folks in Washington, is that we have a state agency, and this principally involves our designers and the regulators, but our designers, where we have a state agency telling us this is how we want you to dig soil test pits so that you can go down in them. But they haven't really harmonized these rules with the excavation and trenching requirements that are also under our labor and industry agency. And so we've got this big disconnect. And we see this happening between our state electrical licensing code as well as our local county codes that have county-specific certification qualifications that allow our guys to change out pumps and floats and some electrical components like that, but doesn't have anywhere in the code that says you got to be a licensed electrician. Same thing here is, as people in the industry, we are making some assumption that the state level agency for the Department of Health in Washington has coordinated or harmonized or reviewed with the State Department of Labor and Industry for the safety requirements on a recommendation that they're making and requirement that they're making on construction of a soil test pit. And it's wrong. Who do I see about that? Right? So just kind of keep that in your mind when you're looking at some of this kind of stuff, and just ask yourself that one question. Does this meet all of the requirements that I have to under the code? Another part of excavation rule that says test pits shall not be left open for an extended period unless properly barricaded for us per L&I regulation. And then they give some examples about what's appropriate. But in Washington, from start to finish, if I'm the property owner and I hire a designer and or an installer to go out and dig a test pit, we submit my plans for that. My permit to build my on-site system is good for 2 years, right? And the way it works on a county-by-county basis, for a number of our counties, they're able to coordinate the inspector from the health department who's going to verify soils along with the designer and or installer same day. So they dig the hole, agree on what the soil type is. This is going to determine what the technology level they're going to get from gravity to mound or advanced treatment, and then they fill in the hole. We have some local health jurisdictions that are so behind that they say dig the pit, leave it open, we'll come up in the next 3 to 5 days and verify the soils, and if we're not there in 3 to 5 days, then you can go ahead and move forward with your submission application and yakety yak yak. And ultimately, though, what has happened because of this 2-year interval in Washington, we have thousands of test pits on property that never got developed for any variety of reasons, that they just didn't get built out, that are open. And the guy that dug the hole owns it, right? And so under the rule, there is some responsibility for you if you dug the hole about what happens next with that. And so you want to also think about that piece of it a little bit. So determination of the slopes and configurations using the appendices. This kind of lays out a couple of your options. There's different charts that look like this in the rule to give you some guidance, and they're also laid out over different depths about how you do this. For us, I've just pulled this one off because the majority of our work is really under this 20-foot maximum. And then we start to get into what type of a soil is it. And so there's type A soil, type B soil, and type C soil. And C is the most unstable soil out of the pack. You can run into ground where there's 2 distinct layers. Again, it just gives you some guidance on what your laybacks are for those if we're using them. And so you shouldn't allow, you think about common sense here, allowing employees to work on the faces of sloped or bench actually at levels above other employees. It's why we wear hard hats, because people kicking stuff down in on people from above. And looking at the shield systems, they got to be designed fit for use to handle loads that they're going to be exposed to, and do it in a manner to restrict movement in there while you've got the guy inside the box. So here's a broad question. If you've got a 20-foot excavation, you've got your trench boxes in place, maybe they're going to be maybe double stacked, can you move those boxes with the employee in the trench? So no. Well, let's take a vote. Who says no? Okay, who says, yeah, oh, it's okay, we can do it? So the answer is, yeah, it's okay, we can do it, but there are limitations. So if you are in a spot where you can get a hold of it and move it and just drag it horizontally, but not lift it at all, that's allowed. If you lift it at all, that's not allowed, and the guy has to be out of the box. So excavations of earth material to a level not greater than 2 feet below the bottom of the shield is permitted, but only if the shield is designed to resist the forces calculated for the full depth of the trench, and no indications while the trench is open that something is happening below that 2 foot level. So these are, as much as anything, I put this in as an example of the flexibility that the rule has for you to make decisions on the ground based on what you're looking at. So when we look at the kind of the 4 things that affect and make trenches hazardous, it's surge loading from weight, water, weather, vibration from equipment, and then depending on how long this the trench is open, soil erosion has ability to play too. So we're back to our guys on their 2,100-foot sewer line that we have. And you can see a couple of things going on here that is limiting a little bit of what they do. And so this is the only place that they can put their surge pile. They are horribly weighting this excavation here, and it's doing what it does. Part of the problem for them laying back, what's the minimum setback requirement from an excavation for your spoil? 2 feet, yeah, that's the minimum. These guys are fighting this because this power line, first of all, they're upslope, and then this power line is fighting them as well. And so they're trying to do their best that they can. The guy down here is pretty exposed, but what he's done here is put a shovel handle, you can just barely see it behind him, so that when he's down there shoveling out this stuff that he backs up, he doesn't step back into the exposure of the trench. It's a good idea, but this trench box is 2 feet up from the bottom. And what the rule says is you can do that, but only if you're not having cave-ins coming in underneath the boxes. And the challenge with this was they thought that the excavation would be 20 feet. Turned out it was 22 feet. Competent person needed to step in. This is the guy that they hired to be from another company that had experience in this level of work, because they had never done a job this big to do that. But just in the couple of hours that we spent on the job, we kind of questioned his functionality and his role as competent person. The ladder was out of the hole. They had this guy in here. They decided to put these steel sheets on either side of the trench boxes so that they could pull it forward. And so they were pounding on these steel sheets, right? The first thing they did actually was they took those boxes and they pounded them down to the bottom of the excavation. They left the guy in there while they were doing that. And then they put these sheets in and they're pounding down the sheets while the guy was in there. And finally, he cried uncle and said, "Get me out of here before you try and move this thing." And so, yeah, sure, come on out. And then they went ahead and moved them. But just the work process flow wasn't really proceeding in a safe manner. And they did all right. Nobody got hurt that day. But really, the one thing they needed to do was to have a double set of boxes, right? Too long, too deep. And that would have just gave them more room to work. So every excavation must have a competent person, and it's one who can identify existing or predictable hazards. You know, we've seen this, and is authorized to change or to make decisions about what's going on. And so when we look at the 3 types of soils that we have, type A soils are they're hard, and as we've kind of worked through this. If you think about Play-Doh, and there's some physical tests that you can do to help your competent person make these determinations. Play-Doh, like if you think about frozen Play-Doh and how hard that would be to stick your thumb into it, that's characterized as a plastic type A soil. Medium soils are like cold Play-Doh. You got to really work at it. And the measure for the thumb test is taking and pushing your thumb into the soil up to your nail base. And that's an acceptable method now by OSHA for the competent person to use for determining the soils. And then granular soils, pretty much all are type C soils that require some kind of protection. A little bit more. So clay loams, try to put a little bit into our language of on-site. So type A soils are fine grained, doesn't crumble, hard to break up when they're dry. Type B begin to get a little bit more granular. There's little or no clay content. They crumble easier when dry. And so when you reach into the spoil pile and you grab a clod of the dirt that's there and you squeeze it with your hand, what is that? You know, what happens next? What does it do? Sand, gravel, loamy sand, then are all type C soils. And so just think about this in context to how we think about soils in general in on-site when we're doing drain field sizing and application loading rates and some of that. It's just a different way that they do it. Plasticity, this is another field test that you can do. It's called a ribbon test. We do ribbon tests on clay soils and on-site for soil determination as well. It's similar. but if you can push a 2-inch length of a 1/8 inch thread and held on one end where it doesn't break, then the soil is characterized as being cohesive. But there's other things that also impact what's going on with the soil. So it's moisture content, freezing. Is it fill? Has it been previously disturbed? Most probably important on this list is surcharge loads of spoil piles, equipment, and then structures that are associated with it. We looked at the previous slide, vibration. What happens to soils when they're subjected to vibration and water, liquefaction? How long is the exposure? And then is there undermining that is going on at all? And so there's a couple of different soil failure modes that happen with, depending on the soil and depending on what's impacting it. One is subsidence and bulging, and then one is toppling. And these all come at you, depending on the soil, a little bit different. Slide failures, this is most common in type C soil, sand. And then subsidence and bulging is where it actually will, it pops out at you at whatever depth the bulge is. We actually just in the last month had a regulator in Washington that was in this picture. And had he'd gone down into the excavation. It was about 6 feet deep, and he started to notice this bulging, and it looked like it was moving to him. And so he started to back out to the edge of the or the end of the excavation, and suddenly it just let loose, almost caught him. He had some material come up about shin high, but he was able to walk out of it and get out. It kind of freaked him out because this pit was constructed to DOH minimum requirements for soil test pit. And so that circulated around DOH a little bit. And what was interesting to me was the response from the home office in the email, because I got copied on this. They said, be safe, it's dangerous out there. Well, how the hell does that help anybody do anything in a soil, in their job out there, right? And so anyway, that's what came out. So is it dentable? Another way of looking at this, if you think about drywall and how hard you have to push on drywall to make a dent in it, then that's a type A soil. If you can push to the bottom of the nail, it's a type B. And unrestricted penetration is a type C. So this is back to our crossing over the street. It's basically they're tying in a sewer line to the house. That is over here, and the excavation of the sewer line is down in there. So they got set up on the job, and they brought all the gear that they needed. They had a trench box, and the equipment he had was this little tractor to put it into place. And once they put it in, it was too low, right? And so your box has to be, or your protection has to be to at least 12 inches above the top of the excavation. And so they fixed that by putting speed loaders and some boards in place there. But some of the things that started to happen next were kind of unique. So this is the soil in place. So it looked pretty stable. It was pretty hard. But for us, this is that glacial till. And as soon as you touched it with the excavator, it turned into a pile of unconsolidated sand and gravel. This is what it looks like out of the pile. So this went from being really a type B soil to a type C soil with any kind of an element added onto it. So they put the box in, but the problem with the tractor and the chain that they had was they short roped it, and so to get it to the bottom of the trench, they ended up the bucket on it was just tight. And so this guy here was a brand new worker, had been on the job for 30 days. And the next thing that happened was we had to unhook the chain. So he jumped in on the box, started to unhook the chain, but he has fall protection, or he's eliminated essentially his fall protection, then down into the trench. And so all of this could have been fixed if they'd done one thing. What was that? Rehook the chain, right? I mean, give it a little bit more distance so he's not bottomed out and has to climb in underneath the bucket on this thing to unhook this under tension. So this is what it ultimately looked like when it was finally seated in the box. And down here is where the pipe is. So they're working away at it and doing a pretty good job. The one big thing that they missed, though, is in the excavation, they're going to be working right down here at the bottom on the sewer pipe that's exposed. And do they need to have any protection here for the end of the trench? Yeah. And so they kind of missed that whole part while they were working. They had 2 workers that were basically down there. And you see the soil profile changing here a little bit from, which is fill on top with the roadbed construction and all that. All has the potential to jump off of there and hit somebody. You can see a little bit better here in this picture. Then again, this is how they had the ladder set up. So it's awkward to get in, and so it just increases the chance of a fall. And you know, my question is always, when you have a deck, what's the minimum height on a deck that you got to put a rail when you're building on your house? It's like 3 feet or something, right? The reason for that also is like with ladders and stuff, and industrial decking and stuff, is that when you come off, you are 1 rotation to falling off a ladder, off a deck, off of this, and basically you land right on your head and neck and shoulders, and the potential for you to have a pretty serious accident is combined. So they continue working to access the pipe, and so this job here, this is the supervisor on the job. The owner is off moving some equipment or taking a delivery, and then this kid here is the new worker. And from there's situational awareness, there is competent person, and there is the attitude of the company here. And what was interesting to me was this guy's supervisor, and he's worked with him for 10 or 15 years, is that every time Gerald, the owner, would go to move a piece of equipment or do something, his supervisor got out of his protection, out of the box, and just ran down a piece of pipe. Would go over here and do something out of his protection, instead of trying to figure out, when they set up the job, how could they move this trench box a little bit easier. And there are solutions to do that out there. The other thing that was happening here, though, was we've got this new worker, right? And so what you permit, you promote. And this guy's been on the job 30 days or so, and he is learning. You know, it's just like a puppy in a litter, right? They're learning what's acceptable for this company to do. So the most common trenching violations that we see from OSHA is no cave-in protection system being used when required, excessive surcharge loads, so spoil piles too close to the excavation, equipment or traffic too close to the operation or excavation, no egress or access for excavations 4 feet or more in depth, and no competent person assigned to the job. And I've done this experiment where I've come onto the job and they know who I am and all that kind of stuff, but I'll say, so who's the competent person on this job? And you know what they do? Not me. It's anybody but me. And so it's really important to make sure that you identify who that is. So another piece of this is an employer working in an unprotected excavation and trench can be cited by OSHA. And so if he's working alone in the trench, so I'm the guy that's going to go in, I'm the owner, but you guys stay out. The employer can be cited, since in the event of a cave-in, you're exposing all the employees for this urgency to try and rescue me as well. Another piece of this is if you're a sole proprietor where you don't have any employees working outside the trench, OSHA has decided that in our citing for our soil test logs, if a county regulator is going to be required to come out and verify soils and they go down in the trench, now you still have the full responsibility of the OSHA requirements for excavation and trench safety on that. So there's more information and training that we do. I said earlier that what we want to do with all of these 3 elements of safety training that we've developed over the last few years with pathogens, with confined space entry, and with this excavation and trench safety, is we'd like to offer those to TOWA to incorporate into your training program going forward. We've got full speaker notes. We'd be happy to come back and support the organization with a train-the-trainer program. And really, the way we do it in Washington is we pull in our guys that do this stuff in the field, and then we frame them with this information, and then they can share their experience and how they saw problems, how they solved problems, and it works pretty well. But we really want to try and get this embedded in the state organizations that have training capability, so that you know, when I'm not here 5 years from now and somebody else is up here doing your training, that this will go on. And you know, I see a lot of, I'll call at-risk seniors in this room, and but there's going to be some turnover that is going to happen here in the next few years, and it's the new guys that are coming in that we also want to make sure that we keep them safe as well. So build your team. Your employees should know enough to keep themselves out of trouble, and make sure that they can recognize these hazards, and give them the freedom to raise the issue to you so that you can address it. So with that, I think we're going to release for lunch, or you're going to do a raffle.
Yeah, well, door prizes.
Door prizes, all right.
Yeah.
All right, thank you.
Thanks, John.